Good afternoon, students. I'll start with the class. In the previous class, we had done the theorem of total probability. Okay, if you had not attended yesterday's class, then it will be difficult for you to understand today's problems. If you have not watched the recording. So the question is, a group contains. So we had solved three problems on that. So now transferring problems similar to this theorem of total probability only there's some transferring which takes place from one place to another. The question is, a group contains 4 boys and 3 girls, and another group contains 3 boys and 4 girls. One person is transferred from first to second group. So we don't know whether it is a girl who is transferred or whether it is a boy who is transferred. And then what you do is, you randomly pick a person from the second group. What is the probability that the person selected is a boy? Now, as per the theorem of total probability, what does theorem of total probability says? P of A is what? Always A is a main event. A is the main event. Then you will have E1, E2, E3 based on what? How many you need. So here there are only two groups. So you will need only two. So theorem of probability will be P of A upon E1 plus P of E2. If there are three events, then this continues with P of E3 and so on. If there are four events, it will continue for four events. As of now, there will be two events, so we will need this as the theorem of total probability. Okay, as in general, it continues P of E3 dot P of A upon E3 and so on till last one is P of En. If E is here, it will always be in the denominator at the side. So now we are solving transferring problem. The sequence which I told you in yesterday's class, it remains the same. The sequence will always be, first you have to write the main event, that is P of A probability, reserve the main event. Then you have to find what is P of E1. Then you have to find P of E2. Then P of A upon E1. This is the sequence for every single problem which will be solving from now till the Bayes theorem, whether it is anything. This is the sequence you need to follow without any changes. Only thing, if there is E3, then here it will be E3 extra A upon E3. Now first question says transferring problem. A group contains 4 boys. So there are two groups. One group is containing 4 boys and 3 girls. So this is group 1. So total how many? 7 people are there. So this is group 1. And group 2 is containing 3 boys, 6 girls. So this is group 2. Now first task, there are two tasks. First one is what? You are transferring one person from here to here. Okay, you are removing from here -1 and you're adding that person over here. We don't know what we are picking, like one person, whether it's a boy or girl, it depends. Okay, and then after adding, this is task 1, and task 2 is one person is selected at random. So what is been asked? After selecting this person from group 2, what is the probability that it should be a boy? So your main event is, what is the probability that a person selected from the second group is a boy? It's asked in the question. Now it depends what are the chances, because this is dependent on this, because this is task 1. You have to know whether it was a girl transferred or a boy transferred. Accordingly, then this one chances will change. Okay. No matter what is the problem, I told you this is fixed. So we'll start framing this. So your P of A is your main event. So A is what? A boy person selected from group 2 is a boy, because that is the question asked, that always becomes a main event. The probability of A we need to find. So this part is done. Now we'll frame E1. Now in the previous problems, when there were 2 boxes, what we used to do? We used to take half probability for box 1, half probability for box 2. But now we know that we are definitely selecting the group 1 first. This is group 1. Okay. So we cannot take half and half probability here. Whenever I go and tell you in the previous problem, when you have to pick a coin, okay, there was box 1 and there was box 2. When you have to pick a coin from one of the 2 boxes, so I give you a task, go pick one coin and come. So you had 2 options now, okay, to select whether it could be from box 1 or it could be from box 2. That's why we have taken E1 as this and E2 as this, box 2. But here the task is, I am going and telling you, go pick one person from group 1. Now this is fixed. Now there's no point you going and checking whether should I select from group 1 or group 2. No. Now the task is, you have to go to group 1 only. And now you have to select a person. Now what is the event? Now you have to decide whether to select a boy or a girl. Okay. So it could be boy or it could be girl. So I don't know now whether you would pick a girl or boy. So we'll see what are the chances that you would pick a boy, or what are the chances that it would pick a girl. So E1, what we'll consider is, anyone will. Either you can take it as a boy or you can take it as a girl. So boy is selected, or you can say that E1 be a boy is picked. A boy is selected from group 1 and transferred to group 2. So what will be the probability of selecting a boy from group 1? What are the chances of selecting a boy from this group 1? How many options you have? 4. Out of how many people? Total 7 people. So probability of selecting a boy from group 1 and transferring to group 2 is, probability it is read of E1. So that will be 4 out of 7. Because 4 boys out of 7. So when you go to pick, you have 4 options out of 7. Now there's one more thing there. You could select a girl also. So we'll see what are the chances if you select a girl. So let E2 be, a girl is selected from group 1 and transferred to group 2. So what are the chances when you go to select a girl from group 1? 3 out of 7. The probability of E2 will be 3 out of 7. So we finish this, we finish this, we finish this. Now we have to frame this. We'll write here. Next we have to frame P of A upon E1. What is P of A upon E1? I told you always read this first. This always you have to read first because this has already happened. So you have to start with always this word given that E1 is what? Go back and check what was E1. E1 what you chose? Given that a boy is selected. And transferred to group 2. Write that same E1 again. Given, you just have to add the word given. Write whatever you had wrote for E1, you just write it here. Group 2. Now, probability that what is A you had selected, the main event, that a boy is selected from group 2. So now we have to calculate if this, what we are saying, if this boy was consider the first one, if this boy was transferred over here. So what is the probability that when you pick up a boy from group 2, what is the probability that it is a boy? Okay, when you randomly pick a person from here, what are the chances? So we are considering this first case. So here only I'll show the calculation because later while studying you should know what will happen. For exam you do this in the rough work. So what has happened now, I am assuming a boy is transferred. So a boy is gone here. Okay. E1 means a boy is gone. The boy is gone means how many boys will be left? So minus one boy here. So 3 boys will be left. 3 girls will be left. Here when you add a boy, so how many boys will become here? 4 boys and 6 girls. Now from here I need to pick from group 2, I need to pick a person. Now what are the chances when you go to pick a person from group 2? You have 4 options because you are assuming that boy was transferred. Now you have 4 options out of total is how much? Total is 10. So P of A upon E1 right below this. Therefore, P of A upon E1 is 4 out of 10. No. Then P of A upon E2. What is E2? E2 is given that a girl is transferred. Assuming that a girl is transferred from group 1 and transferred to group 2, probability that this will not change. A is not changing. See, A is that only. Probability that a boy is selected from group 2. Main event remains the same. A. Probability that what is A? Boy is selected from group 2. So now let us see what are the chances that a boy person selected is a boy when if a girl was transferred. This will never change. The main question will not change. We have to choose probability for a boy only. Whether girl is transferred or boy is transferred, this remains same. You have to calculate probability for a boy only. Because the main question asks for a boy. We'll calculate the same data. I'll write again. So when a boy is transferred, what is going to happen? A girl is transferred. How many girls will remain? 2 girls and 4 boys. So you're adding a girl. So boys will be 3 only, but girls will become 7 girls. Now what are the chances that the person is a boy? This has not changed. This is your main event A. What is the probability? Can anyone tell me? What are the chances from here when you go to select? What are the chances that from here if you select a person it has to be a boy? How many options you have now for a boy in group 2? How many options are there of selecting a boy from this group? How many boys are there in group 2? This has, now what question I'm asking has nothing to do with the previous class. I'm just asking what are the chances of selecting boy, okay, from this group. On answer fast. Yes, 3 out of 10. So P of A upon E2 will be, if girl was transferred, then you have only 3 boys. So that will be 3 out of, if boy was transferred, then you have 4 out of 10 options. So you framed all of this the moment I told you this is your task. You have to find all these 5 things. This is your main event, this is done, this is done, this is done, this is done. Once I do this, you just have to multiply this. P of A is always equals to this into this plus this into this. That's our total theorem formula. So P of A will be P of E1, P of A upon E1 plus P of E2 not P of A upon. Just multiply the answers. E1 was how much? 4 out of 7. E2 was how much? 3 out of 7. 3 out of 10. 16 out of 70 plus 9 out of 70. 25 by 70. 5 by 14 will be done. It's a P of A. Okay. If you have any doubts, let's solve the second one. After that, in case you don't understand something, can ask. The second question. A box contains 4 white and 6 black balls. Another box contains 3 white and 5 black balls. One ball is drawn at a random from the first, same like how either it could be boy or a girl. So now it could be the white or black. Okay, one ball is transferred from the first group to the second group, and then a ball is selected from the second. Find what the probability that it is a white ball. Same boxes you have to draw and just put the data in. So what you need to do is the box contains 4 white and 6 black balls. This is the first group, means box 1. The box 2 contains 3 white and 5 black balls. This is box 2. Now same thing, one ball is transferred, so you don't know whether it is black or white. And then one ball is removed from here. After transferring, this is the second task. So this is task 1 and this is task 2. So task 2, what is been asked? The main event is this ball has, what are the chances that this ball is white? Now it depends on two things. What if the ball transferred was black or if this ball transferred was white? Accordingly, these numbers change. So same order. First you have to find A. There are only two boxes. E1, this will be E2. Means only two options. Either it could be black or it could be white. So it is just E1, E2. Then you know, whenever you have E1, then you P of A upon U. This either you want to by heart the order, do whatever, but remember this order only. In case your college uses some different notations, it becomes very confusing. Okay, they use B for black, W for white, and then every problem you have to think what was the order. So keep this in your head. Stick this no matter what is there, whether black, white, marble, whatever it may be, girl, boy, everything. Just name it as E1, E2. Best. Becomes easier to remember this sequence. Okay, so we'll start with the main event. Main event is always your question. The main event. So that's the A. A is what? Ball drawn from group 2 is white. So what is P of A? What is the probability that the ball drawn from group 2 is white? This is the first part done. Next is the E1. E1 is now what? Either this could be white or black. Any order you can take. E1 you could take black or this. Anyways, we'll go in the same sequence. The E1 will assume a white ball is selected. Suppose if this is a white ball selected from box 1, sorry, box it is from box 1 and transferred to box 2. So what becomes the probability? When you're given a task, go pick a white ball from a box 1. So what are the chances that you would pick a ball from box 1, white ball from box 1? Can anyone tell? What is the probability of picking a white ball from this out of this total? It's basically always how many that thing upon the total. How many white balls upon the total number of balls. So what will be the answer? P of E1. What will be P of E1? When I ask go pick a ball from box 1 and it has to be white. So what are the chances of being white? How many options do you have of picking white balls? Yes, so that would be 4 out of 10. So that becomes the probability of picking a white ball from box 1. Okay, so you're picking and then throwing it here. chances are 4 out of 10. You can write it as 2 out of 5 also. You can leave it like that. Later we'll see while calculating. Next, E2 is you have to pick a black ball then. A black ball is selected from box 1 and transferred to box 2. Same thing you have to write. So what are the chances of it being black? Is 6 out of 10. So we did this. Now this. How to read, I told you have to always start with given. E1 means read here, go back here. Given that a white ball is transferred, you can write shortcut also. So you can write full thing also. Selected from box 1 and transferred to box 2. Probability that, what is A? A is this ball drawn from, you have to always read ulta. This given that and this. So probability that ball drawn from box 2 is white. So we'll see what are the chances of this being white when a which white ball was transferred. So under this, draw this box again. So when a box, this is a main one starting. So you're assuming this one white is been transferred. So here minus 1 white, here plus 1 white will become. So here 3 white will remain, 6 black. Here how many will become? 4 white, 5 black. And then you're picking a ball. So this has to be white. What are the chances that a white ball is picked up from here? So when you go to pick now, the task 2 you are doing, so based on this was transferred white, so you have 4 out of total 9 of them. P of A upon E1 is right after this also. 4 out of 9. The same way now, P of A upon E2. Given that E2 means what? A black ball. Transferred from ball was picked, was selected. Same you write everything E2, whatever you did it. Selected from box 2 or box 1 and transferred to box 2. Probability that, what was A? Ball drawn from group 2 is white. That will not change. Will be white only. Same thing. 4 balls were there. So you're taking a black ball now. So minus 1 black. Here 1 black will get added. So 4 white, 5 black. Here 3 white only and 6 black. But here the chance, this has not changed. What are the chances it to be white from the group 2 now? So white anyways remains 3 out of 9. 3 options out of 9. So P of A upon A2 It means when black was transferred, what is the probability that is said to be white? 3 out of 9. So you got all the 4 things. Now multiply. Substitute. What was P of E1? E1 was 4 out of 10 into the 16 upon 90 plus 9 upon 90. Sorry, 18 upon 90. Calculate and then write your answer. So that will be 34 by 90. 17 by 45. Same thing, question 3. So bag 1 has 3 red and 4 black, whereas bag 2 has 4 red and 5 black balls. So 1 is transferred, same thing. Whole thing remains the same concept. So I just frame and give you all. It I can just multiply. You just have to basically draw the diagram. 3 red. This has 4 black. The other one has bag 2 has 4 red and 5 black. Something has been done. Then one ball is picked. So what are the chances this has to be black? Same thing, main event. Main is ball drawn from bag 2 has to be black. So what is the probability of A? You need to find. E1, now you have 2 options. First, a red ball is picked and transferred. So when you go to pick a red ball from bag 1, you have 3 red balls out of total 7. The chances of picking, how many options you are picking red ball? 3 options out of total 7 options. Out of total 7 balls, you have 3 red out of 7. So these are the chances. Same way, E2, a black ball is transferred. The probability of E2 will be, how many options you have? 4. So the sequence, the order will never change, I told you. So A is done, E1 is done, E2 is done, P of A upon E1. So read from here, given that E1 is what, just refer here. A red ball is selected. From bag 1 and transferred to bag 2. Probability that, what is your main event? A means ball drawn from bag 2 is black. Now draw the diagram. Yes, right. After transferring, what happened? Now I'm assuming that red ball is transferred, so there will be 2 red minus 1 red, yeah, plus 1 red. But the chances asked a black ball when the red was transferred. How many options you have for black? 5. 5 black balls out of total 10. Because the question is asked for black now. If they had asked for red, it would be again 5 out of 10 only. Now P of A upon E2, given that probability that ball drawn from bag 2 is black. This will not change because A is same. Now we'll see what happens. Your black ball was transferred. So 1 black minus here, not from here, this one. The main, you have to refer the diagram. Don't take from here. This is separate. Now this is with reference to the original diagram. So total how many were there? 3 red, 4 black. So 1 black is gone. So 3 red will be there. 3 black. Other side 4 red. And it will become 6 black. The ball transferred should be black only. So what are the chances when you go to pick up black? How many options you have? Six out of 10. Because the question asked is black. If they had asked red, then it would be 4 out of 10. And P of A is multiply P of E1 39/70 will be the answer. Anyone having doubt in this, you can ask. Okay. Next one, the fourth one is slightly different because till now the first three problems there was only one thing drawn. Either one girl was transferred, one boy transferred, or one ball was transferred. Now the last one is slightly this, when two things are transferred at a time. Which are the problem? What? 1 second. Okay. This is the fourth one. One bag has 5 white and 4 black balls. Other bag has 7 white and 3 black balls. Now 2 balls are transferred. Now you see now what to be done when two things are transferred from first bag, and then one ball only is drawn finally at the end from the second bag. What is the probability that the ball drawn is black? So whenever more than one things are picked up at a time, no, you have to use something as combination method. So before doing that problem, you just explain. Randomly, I'll just explain when to use combination. Now there's a box. Maybe there are 5 red and 8 black, suppose. Okay, this is when one ball is picked. Actually, everywhere there is combination applied, but we normally don't use here because it is simple. Whenever one ball is picked, now I want to find of red. Probability of red, it is very simple. It's always this upon the total is how many? 13. The probability is red is what? 5 out of 13 is the chance. Someone asks you what is the probability of black picking a black ball? It is 8 out of 30. So we normally divide by the total sample space. Okay. How is this arrived is basically out of 5, it is same as what? Out of 5 red, you are picking 1. And what is the sample space? Total how much? Out of 13, that is what? You are picking 1. But anything like that, NC1 is always equals to N only. Okay, NC1, right here and keep, but NC1 is N only. So visually we don't go to write this. So directly we write this. So 5 out of 30. But logic wise, if you go to see using combination formula, it applies for actually every problem. I am selecting one ball out of 5 balls. Okay, so our sample space is what? You're selecting one ball out of 13 balls. So that's always divided by sample space. So which is nothing but 5C1 is anyways 5 only, and 13C1 is anyways 13. So it's like basically same thing. But whenever we pick up 2 balls now, and 2 balls are picked, or maybe even 3 of them later, it applies for 3 also. Probability of red. Okay, suppose probability that both are red. both are red means how many you have to pick, how many options you have? 5. Now it would be 5C2 because you are picking 2 red balls out of 5, and sample space would have been 8 red, this 13. We are picking 2 out of the total 13 balls. Probability of both black would have been 8C2 because we are picking 2. If the question was 3 balls are picked and all 3 are red, and it would be 3. So this would have been 13C2. And suppose now if they ask one black and one, there are 3 options, no? Either both could be red, both could be black, or one red and one black. The third one is one black and one red. So you have to pick one black from here and one red. How many options you have for black? Out of 8, you are picking one ball. And n means always multiplication. And out of 5, you are picking one red ball. This will be same. This 13C2. So one red and one black. Yeah, both red means 2 red. Yeah, 2 black. Yeah, one black and one red, and 8C1. From 8 I'm selecting one black, and from 5 I'm selecting one red. Overall sample space is what? Out of 13, finally I'm selecting 2 black, 2 balls. So these are the 3 options whenever you pick up 2 balls. So whenever you're picking more than one, you always use like this combination. So now we'll start solving question number 4. Question number 4 says there is one bag which contains 5 white and 4 black. Here 7 white, 3 black. Now here 2 balls are transferred. Okay, so I will just write 2 balls. 2 balls are transferred here. Here and I'll write like this and keep 2 arrows I'll put. So these are the 2 balls. And now here from here there's only one ball picked from the second. First this is task 1, transferring, and then this is task 2. So this ball it is asked has to be black. In the previous problem, if this was just one ball, as how we have solved in question 1, 2 and 3, if this was just one ball, what it would have been? E1 and E2. E1 would be that you are picking white ball, and E2 would be that you are picking black ball. So you would see both the cases where if white ball was transferred, what is the probability? And if the black ball was transferred, what is the probability? Now there are 2 balls. Now there are 3 things which can happen. Could be both white, second one, both of this are black, or there's a third case, one black and one white. Now there are 3 cases, 3 options you have of transferring the 2 balls. You could transfer both white or both black, or the third case would be one black, one white. So there will be 3 events now, E1, E2 and E3. So what will be a main event? Main event is anyway A, that is ball picked from bag 2 is black. So that is what we have to find. P1 will be what? Both red, means 2 red balls. Both red means 2 red, sorry, not red, white. 2 white balls are selected from bag 1 and transferred to bag 2. So let us find what is probability of E1. So now you have to select 2 balls from this bag. So now you have to use combination formula. The combination means you have to select 2 white balls. So how many options you have? 5. So out of 5 white, you are selecting 2 white. And sample space will be how much? Total 5 plus 4 is 9. From 9 you are selecting 2. This is your sample space. How to calculate NCR formula? NCR is n factorial upon n minus r factorial into r factorial. NCR is n factorial upon n minus r into r factorial. So this will be 5 factorial upon 5 minus 2 factorial into 2. 9 factorial upon 9 minus 2 factorial into 2. 2 and 2 alternate can directly cancel. So this will become 5 factorial upon 3 factorial, 9 factorial upon 7 factorial. This is, make it ulta. A upon B, C upon D, Z reverse. Now we have to simplify. Now for factorials, we should know that you can, factorial is nothing but what? You have to go on expanding that number. 5 factorial is what? 5 into 4 into 3 into 2 into 1 till you reach 1. Okay, same thing, 7 factorial will be 7 into 6 into 5 that we had done in 11th standard. So there's a shortcut which you can simplify rather than expanding the whole number. Out of this is a bigger number. So bigger number I have to start expanding. 5 factorial I can always write it as 5 into 4 into 3 factorial. You can stop here. Then out of this 7 I'll keep here. 9 I can always split it as 9 into 8. The moment you reach the other one, you stop. So this will be 5 by 18 will be the answer. Now we'll take event 2. E2 is what? Both black and 2 black balls are picked, are selected from bag 1 and transferred to bag 2. So what is probability of E2? What was there? In bag 1, 5 white and 4 black. So now you have to pick 2. Okay, this is the case where at the side only you can write 5 white, 4 black. Here you're picking 2 black. You're transferring 2 black. So what are the chances? You have 4 options out of 9. This is because there are 4 black available in bag 1. And from 4 you have to pick 2 black. This will be 4 factorial upon 4 minus 2 factorial. Same with 9 factorial. 9 minus 2 factorial. 2 and 2 will cancel. This will go reverse. 7 factorial upon 9. The bigger number you have to split till you reach the other one. Out of this is the bigger number. 9, 8 into 7. So 1 by 6. Practice those factorial. In case you have forgotten, you want a 11th standard video to see how to solve factorials, you can ask her. I can send. So I cannot waste time explaining the 11th standard again, the entire concept. In general, whatever is needed, I have told. I want to practice more on factorial. That's up to you. Okay, I can send problems if you want. Until and unless you all show some interest, why I should put extra effort. And if you are lost, I'll say. If you all know factorials, good enough. This is 1 by 6. Then the third case will be now 1 black, 1 white, you can say 1 white. Order doesn't matter, okay? And 1 black. Total it is 2 only. From bag 1 and transferred to bag 2. One black is selected, 1 white is selected. P of E3 will be what? So you need 1 white. So how many options you have? 5. So from 5 white, I'm picking 1 white ball. And n means always use a multiplication. No? From 4, I'm picking 1. So this is for black. Upon total will be 9C2 only for everyone. Total sample space 9 out of 2 out of 9 without any condition. 5C1 is anyways 5 only. The moment this is 1, no need to calculate, straight away it is 5. 9C2 will be 9 factorial upon 9 minus 2 factorial into 2. When you reverse, this will be taken as upon 1. Oh no, this is taken as 1 now. This will become ulta. Now calculate. This will be 5 into 4, 7 factorial. 2 factorial is anyways 2 into 1. 9 into 8 into 7 factorial. 7 and 7 will cancel. 4 to the 8. 5 out of 9 will be the answer. Probability of E3 is 5 out of 9. So P of E1, E2 and E3. Very less chances of this problem because only once it has come in the question paper. But I don't want to skip because in case it comes, you should be able to know how to solve. Then which all orders will be now? A is done, E1 is done, E2 is done, E3 is done. So we'll have to find P of A upon E1, P of A upon E2, P of A upon E3. We'll start with P of A upon E1. Given that two red balls are transferred, are selected from bag 1 and transferred to bag 2, probability that ball selected from bag 2. Now only one ball is selected. So now what is going to happen is you are transferring, you have already transferred. Given that means it has already happened. I am moving on to task 2. So two red, I am transferring two red balls. So how many will remain? Two red balls means, sorry, what is that? White. First E1 was white, no? So two white you are transferring. So how many will remain in the first box? If you are removing two white, only three white will remain here and two black. So minus two white balls here plus two white balls. That will become 7. So that will be 9. So it will become 9 because there were 7 of them before. And now one ball is removed. So that has to be black. Now here there is no permutation combinations because only one ball you are picking. So if you are picking one ball, now you have to use combination. P of A upon E1 will be, so it has to be black. So total will become 12 balls. Total is 12 balls. 3 out of 12. P of A upon E2, given that two black balls were transferred. Probability that ball selected from bag 2 is black. That will not change. Now we are transferring two black. So only two black will remain here. So minus two black. So here you are adding plus 2. So total 5 black will become. White will remain the same one. From 3 they will become 5. And so one ball is picked. What is the chance? It has to be black. How many options you have for it to be black? 5 out of 12. 5 black out of 12 balls. This is also for black one. Yeah, it was 3 black out of 12. And the last one, A upon E. Given that one white and one black was transferred. Probability that was same thing. Probability that ball from black to was black. And then the two boxes. So now one black, one white, and one black is transferred. So minus one white, minus one black, plus one white, plus one black. From here, one will reduce. You have to add. So this will be 4 white remaining and 3 black remaining. Here, if you add, they will become 8 white and 4 black. So that has to be black only. What are the chances now for it to be black? 4 out of 12. Then multiply all the answers. Substitute all the answers. I don't have those values here, okay? I missed out in the previous problem. So whatever it is, you just substitute. E2 is how much? 5 out of 12. This I think was 1 by 6. Just check after calculating. This is how much? E3 is 4 out of 12. Just put all the values here and then calculate. So it's there in the sequence. Just substitute as per that. Alright, done. So I'll stop here. In the next class, I'll start with the Bayes theorem. That's the last part of probability. And it's a very important topic because one problem is there for sure for 4 marks. So this has a 7 marks. This is a 7 marks chapter. Out of that 7 marks, 4 marks will be surely for Bayes theorem. There are few times it comes with this transferring problem. Okay, or this, what is the total probability? There are less chances, but Bayes theorem 90% of the times, you can say 95% of the times, there's one Bayes theorem problem there. That's all. Any problems on that? Please attend the next class and just go through this formula again, because again it's dependent on today's type only. Just one small twist is there, only one extra formula, that's it.